All right, this is Mr. Jern, and I'm going to talk about AP Physics 1 Workbook 1C, average versus instantaneous speed. We have a scenario where a toy company claims to have developed two toy car models, which they call Car A and Car B, where the average speed of each car is identical, so about 0.50 meters per second, plus or minus a little bit. Each group of students is given two toy cars, one of each model, meter sticks, and stopwatches, and is asked to test the toy company's claim. So experimental design is something that is there's literally an FRQ called something close to experimental design. You're going to design an experiment, a hypothetical experiment, without actually having access to the equipment. There'll be similarities to experiments we do and labs we do in the class, but there's probably not going to be identical. So keep that in mind. Okay, it's very rare that you're going to have the identical exact same experiment, but it'll be similar. We're using similar tools. The students decide that they need to collect distance and time data for each car to test the company's claim. The students design the procedure. Now, keep in mind what the students have access to. They've got meter sticks, stopwatches, and they've got the two toy cars. So keep that in mind as you go forward. Cross out any extraneous steps and order the remaining procedural steps. Okay. You want to focus your steps on data gathering and then reducing error. Okay, so I've taught you one method. There's many ways to do this. So gather equipment is crossed off, and that's just because that's extraneous. You don't. It's obvious that you're going to have to gather the equipment. Please don't waste people's time, readers' time, experimenters' time by including the step to gather the equipment. What does that even mean, right? Gather the equipment, like you're herding sheep? No, it's something that's obvious. And I know different teachers have different philosophies about it, but I'm telling you that on the AP test, that's extraneous. You may or may not get points taken off, but it's not going to help you. All right. Draw a data table in your notebook is also a little bit personal or specific to the experimenter. It doesn't really matter how you organize your data. There's another step over here. It says measure and record. So right there, it's already taken care of. Okay, you record it in the way that works best. You don't have to draw data. I mean, you probably should, but especially saying it in your notebook. Maybe you're not using a notebook. Maybe the person reading it is not going to use a notebook. Maybe there's something using something else. You get the point. So then we take these and what makes sense. Measure a 2-meter long path on the floor. Now they didn't say what to use, and I actually don't like that. I would have included using the meter stick, with a meter stick somehow in there. That's not included as an option, but so I would have put it in there. And you should too. We'll work on that throughout the year. I would always include the tool that you're using to make the measurement. Turn the car on and release along the measured path. That is important to do and mention. You can combine these steps, of course, if you like. It's kind of how we do it in class sometimes. Measure and record the time the car took to travel 2 meters with a stopwatch. So in this case, they actually did include the tool or the instrument that you're using, and I think that's very good. I think that's a good idea. Step 4 is always important. You should always include that. Repeat to reduce error. If you want to be more specific, you can, but definitely include that as a step. Part B. Given is a data set collected by students in the class. Based on these data, what conclusion should the students make about the hypothesis that the two cars, A and B, have the same speed? Okay. It says the averages are the same. Look at that. Hey, already done. Add all up, you get the same numbers. Add them up, divide by 6, boom, 0.49 every time, right? But you got to look closely. You got to look closely. What is going on here with Team 5 with Car A and Car B? What Team 5? Something's wrong with Team 5. Something happened. No judgment there, but something is different. All the other teams have roughly the same numbers, right? And for the specific car. But then there's Team 5. All right, I don't know if they're having a bad day or just faulty equipment or what. Doesn't matter. Those are what we call outliers. All right. Outliers are data points that clearly don't match the trend that you would expect and that the other data are showing you. And it's okay to ignore them or delete them or revisit them or remeasure them or question them in some way. Okay. Don't just say, well, that's the way things are. No, you got to use your brain a little bit. Okay. You're not a robot. So look for outliers. If they exist, then deal with them in some way. And then if you take away the outliers, the averages are definitely going to be different. Part C. The students, this is experimental design. The students decide that additionally, they want to test a toy company's claim that the car's speed is constant throughout the motion. Constant. Okay, that's a word you're going to see a lot. How, if at all, does the experimental procedure from part A need to be modified to verify the car's instantaneous speed is constant? Now, instantaneous speed is different than average speed. Instantaneous speed is like the speedometer on a car. It could be it's whatever speed you're going at that instant. So you might be like to go from Joliet to Chicago is about 50 miles. If it takes you 1 hour to get from Joliet to Chicago, you traveled about 50 miles an hour on average. 50 miles in 1 hour. The average speed is 50 miles an hour. But were you going 50 miles an hour the entire time? No. You had stop signs, you had stop lights, you were going probably faster on the highway. So your instantaneous speed varied, but your average speed maybe was 50. So Angela got it correct because, I underlined the wrong instantaneous. Oops. So Angela got it correct in that you want to use motion sensors to get speed versus time for the entire trip. And if you get a graph that basically, if you could picture this graph, um, so it says speed versus time. So speed versus time. As time goes on, if your speed is roughly a straight line, that means that your speed never changed. It's got a constant speed. Blake wants to use the photo gates positioned at the beginning and end of the 2 meter long track to determine the instantaneous speed of the cart. The problem with that is he's going to get the speed for Blake. He's going to get the speeds maybe at the beginning and at the ending, but who knows what's going on in the middle, right? I mean, it could have gone up and down and up and down, and who knows what's going on in between. And all Blake is going to get is this part and that part, the beginning and the ending. So that's why, I mean, we'll use photo gates throughout the year. You'll be more familiar with those. And so that's why Angela is correct.